So here we have a graph. This is called a PV graph. So this is pressure, this is volume. So from this graph we can calculate the work actually. So what do we have to do here? We have to basically calculate the area of this rectangular shape. Okay, so in order to calculate the area of this rectangle, I think you know that you have to just multiply the length of the sides. So here the length of this side will be equal to P, and the length of this side will be equal to what? Delta V. So this brings us to the formula. W is equal to P delta V. So we have different cases when delta V is bigger than 0. So it means that the volume increase and the work done by the gas is bigger than 0. If delta V is smaller than 0, then work is also smaller than 0. If delta V is equal to 0, it means that the work will be equal to 0 as well. So here we have no work actually. Okay, so now here we have a problem. So here we have to pay attention to the numbers that we have and the units on the graph. So here firstly we have to pay attention to the pressure. Pressure is given in kilopascals. So here the length of this side will be equal to 150 kilopascals, which is equal to 150 times 10 to the power of 3 pascals. So we have to make sure that we have here pascals, not kilopascals. And the length of this side will be equal to 3, right? So 5 minus 2 is 3. So delta V here is equal to 3 cubic meters. Okay, so we just substitute the numbers. So our work in this case will be equal to P delta V. So P is equal to 150 times 10 to the power of 3 times 3. This is equal to 450 times 10 to the power of 3, which is equal to 450 kilojoules. Okay, you can just write the answer in kilojoules. And I think this one is the last problem for this lesson. As a gas expands under the constant pressure of 100 kilopascals, so we can immediately write P is equal to 100 kilopascals. If we convert this into pascals, this will be like 100,000 pascals, or 10 to the power of 5 pascals. The volume of the gas increases by 0.5 liters, so it gives us delta V. So delta V will be equal to 0.5 liters. 0.5, if we convert this into cubic meters, will be equal to 0.5 times 10 to the power of minus 3 cubic meters. And it absorbs 175 joules of heat. That means that our Q will be equal to plus 175 joules. So what is the change in internal energy? So from the first law of thermodynamics, we know that Q is equal to delta U plus W, right? If we open this W, we will have delta U is equal to, not delta U is equal to delta U plus P delta V. So we have to find this delta U. That's why you can write like this: delta U is equal to Q minus P delta V. So by the way, we have everything here, so we have to just substitute the numbers. So we will have like 175 minus P, which is equal to 10 to the power of 5, times our volume, which is equal to 0.5 times 10 to the power of minus 3. So minus 3 and 2, minus 3 and 5 cancel out as 2. So we will have 0.5. So here 175 minus 0.5 times 10 to the power of 2. So from here we will have 50. So 175 minus 50 will be equal to 125 joules. Okay, so this is our change in internal energy. That's it for today. Good luck in your future lessons. Goodbye.